Today in class, you are going to be taking notes in your journal and listening to definitions and writing those definitions in your journal over unbalanced forces. For the next 2 weeks, we will be focusing on how to demonstrate and calculate how unbalanced forces can change the speed and direction of an object's motion. So in your journal, you should have already done a triangle fold and titled that triangle fold Force and Motion, and you should have already added force and motion notes to your table of contents. The first term that you are going to write is force, and you're going to underline the term, and you are going to write the definition here of a push or pull that can change the motion of an object. Remember, as I'm talking about the slides, you may pause it and rewind at any time so that you have time to take and write the definitions in your journal. The next term, I want you to skip a line after your last definition and write balanced forces and then underline it. Balanced forces are forces on an object that do not change the motion of the object. So in this case, we have two arrows. They're pointing in opposite directions, and I want you to note the width and the length of those arrows are equal, showing that they are balanced forces. They're working in opposite directions, so you're not going to have any motion here with this rope. In the box, again, you have arrows that are equal and opposite, so they are considered balanced forces. I'm going to show a little option here with a pen. We measure forces, you learned in 7th grade, with newtons. So let's say I have 2 newtons of force to the right and 2 newtons of force to the left. When they're in opposite directions, you subtract those forces. And my handwriting is very bad with this. So you get a net force of 0. That would be considered a balanced force. The next term I would like you to write is unbalanced forces. Again, remember to skip a line after your last definition, underline the term, and then write the definition here. For unbalanced forces, those are forces on an object that cause change in the motion of the object. So here, notice we have 3 people in the tug of war, so notice my arrow is thicker and longer. So let's pretend that those 3 people have a total force of 20 newtons. And then let's pretend that these 2 people are pulling in the opposite direction and they have a force of 15 newtons. So when you subtract, since the arrows are in opposite directions, you subtract. So 20 minus 15 gives you a net force of 5 newtons to the left, because the left motion is the higher newton number. So the motion would move towards the left. The same thing occurs with the box. We now have unbalanced forces, so the motion of the object would be to the left. A net force is calculated when you take into account all of the forces acting on an object. So add net force to your definitions. It's the sum of all the forces acting on an object. So you have the weight of the plane, which is a force going down. You have the thrust of the jets that have a force going towards the left. The plane is obviously going to have some drag or wind resistance, which would be a force to the right. And with this drag, it creates lift with your wings, which is what keeps the plane in the air. So you want to make sure that you always have a higher force going up and a stronger force going with your thrust to keep your plane in the air so that you don't crash. So in net force, the key thing, and I want you to write this definition here, is if the arrows are in the same direction in a diagram, you're going to add those forces together. If arrows are in opposite directions, you're going to subtract those forces. And so you may have an instance, well, not only do you have, a force to the left and a force to the right, you might have 2 forces from the bottom, and you're going to have to add those together because they are working together. And these you would subtract. So that is how we're going to have to calculate how forces might affect an object's motion. The next thing is when an object is not moving, we call that at rest. So at rest is our next definition. The state of an object when it is not in motion. If this is the case, not in motion, we know we must have balanced forces. Well, what is motion? Please add motion to your definitions. Motion is the change in an object's position with respect to time and in comparison to the position of other objects used as reference points. You can really only tell that something's moving if it is moving in a different spot compared to something else as a reference point. And we will talk about different types of motion again tomorrow. So, forces can affect motion in these 6 ways. So please add these to your notes and copy all 6 bullets. First is, if you have a force, it can make an object start moving. Think about what you did in class with the marble or the tennis ball. You could apply a force and make it start to move. If the ball was moving, you could apply a force in the same direction of the motion and it would make it move faster. You would inherently have the object slow down, and we will talk a bit about friction. So forces can make objects move slower. That's the reason objects do not continue on and on forever on Earth, because we have gravity and friction. They can also make objects stop moving altogether. You were able to make your marble or your tennis ball completely stop moving because of a force that you created. You could also make the objects change direction. And lastly, and we did not do this, is we could make objects change shape. If you were to squeeze some Play-Doh in your hand, it would make it change shape. Also think of a car accident. When you run into something, the car can change its shape. That should be the end of your notes. Have a good day.